In the previous lecture, we saw the one example. Okay, look at it. Is it the screen is visible to all?
Yes, sir.
Okay, now look at here. In the last example, we write that C3k is equal to minus 1 raised to k plus 1 into minus 1 into C naught 1 8 17 26. Okay, these terms. Okay, instead of here k plus 1, take here only k. Okay, they can have instead of k plus 1. नीट लक्ष द्यायला.
सर काही जणांना जॉईन होता येत नाही.
आवाज येत नाही का? जॉईन होत नाहीत का?
जॉईन होत नाहीत.
म्हणून पटकन म्हणतो. ओके, the C3k terms is minus 1 raised to k, okay, into minus 1. Okay, wait a minute. Minus 1 raised to k into, okay, 1 into minus 1 into 1 into 8 into 17 into 26, and upon the denominator terms is 3 into 2 into 6 into 5 into 7 into, okay, 6 into 5 into 9 into 8. These are the terms. Okay, up to so on. Now put k is equal to 1. What we get? K is equal to 1. C3 is equal to, okay, C3 is equal to minus raised to minus 1 raised to 1 is, this is minus 1. Okay, आणि हा तुमचा जो मायनस 1 चा कोएफिशिएंट आहे तो इन जनरल टर्म मधला आहे, हा 9k minus 1 मधला आहे. Okay, hence if we put k is equal to 1, here we get C3 which is equal to minus 1 raised to 1 is minus 1. Okay, जेव्हा फर्स्ट टर्म घ्यायची तेव्हा k is equal to 1 ठेवलं की हा तुमचा फक्त ओनली मायनस 1 येणार इंटू मायनस 1. दिस इज इंटू सी नॉट. ओके, इंटू सी नॉट अपॉन, आणि खालचे फक्त दोनच टर्म्स येतील, 3 into 2. Okay, is it the value of C3? C3 is equal to C naught upon 3 into 2. Okay, this minus minus get plus. Now put k is equal to 2 now. So what we get? C6 is equal to minus 1 raised to 2 is plus 1. आता काय येणार? हे दोन टर्म्स येतील, हा 1 नाही येणार, हे दोन टर्म्स येतील, minus 1 into 8. ओके, इंटू सी नॉट, आणि खाली किती येणार? हे दोन तर येणारच, इन जनरल लिहितोय आपण, आणि ह्याचे पुढचे पण दोन येणार, 3 into 2 into 6 into 5. Is it minus 8 into C naught upon 30? 3 into 2 into 6 into 5 आहे का? Wait a minute.
सर अजून काही ना जॉईन होता येत नाही.
हॅलो, जॉईन होत नाहीत का?
हो.
म्हणून पटकन वेळेवर जॉईन व्हायला पाहिजे. झाले की okay. Now put k is equal to 2 here. We get C6 is equal to, जेव्हा k is equal to 2 ठेवेल तेव्हा काय येणार? minus 1 raised to 2 is plus 1 here, and first two terms आणि खालचे 4 terms येतील. Hence it is the value of C3k, that is C6 is equal to minus 8 into C naught into 30 to 3 into 2. Okay, now put k is equal to 3 now. What we get? C9 is equal to, आता किती टर्म्स येतील याचे? फर्स्ट 3 टर्म्स येतील आणि खाली 6 टर्म्स येतील. Okay, minus 1 raised to 3 into minus 1 into 8 into 17 upon this is C naught upon 3, 2, 6, 5 into 9 into 8, which is equal to minus 1 into 1, minus 1 is plus 1. So here we get 8 into 17 into C naught upon the denominator as it is. So this is the value of C9. Look at it. Okay. Now, any doubt? जेव्हा फर्स्ट टर्म घेऊ आपण तेव्हा फर्स्ट एकच कोएफिशिएंट येईल k इज इक्वल टू 1 घेतल्यानंतर. k इज इक्वल टू 2 घेतल्यानंतर मग हे दोन टर्म्स येतील, खालचे 4 टर्म्स येतील. ओके, k इज इक्वल टू 3 ठेवल्यानंतर वरचे 3 टर्म्स येतील आणि खालचे 6 टर्म्स येतील. Okay, so in general we can write this 9k minus 10 and this is 3k into 3k minus 1. मग इथे काय चेंज होईल? मग इथे काय होईल? मायनस 1 रेस टू काय होईल? इथे k होईल. ओके, इथे काय होईल? करस्पॉन्डिंग चेंजेस करत जा तिकडे. मायनस 1 रेस टू k. ओके, इथे काय येईल? मायनस 1 रेस टू k. ओके, त्या नोट्स मध्ये, कालच्या दिलेल्या नोट्स मध्ये तेवढे हे करा. Okay, correction kara तेवढे. Okay, so this is the phi 1 of x, this is phi 2 of x. Okay, now any doubt? आवाज ऐकू येतोय का?
हो सर.
Yes, sir.
Have you solved it, this example? Generalization काय आलं याचं? C3k काय येतोय? काय येतोय का बघा? C3k is equal to C naught upon 3 into 2 into 6 into 5 up to so on 3k into 3k minus 1. Okay, आणि 3k plus 1 काय येणार? C 3k plus 1 is equal to C1 upon 4 into 3 into 7 into 6 up to so on 3k plus 1 into 3k. Okay, so this is, and C 3k minus 1 is equal to 0. Okay, check kara hai. Now we move towards the next point, Legendre's equation. What is the Legendre's equation? Legendre's equation. हे आज होणार नाही, आज आणि उद्या. आज हाफ पार्ट होईल याचा आणि उद्या हाफ पार्ट होईल. ओके, नीट लक्ष द्या कॅल्क्युलेशन कडे व्यवस्थित. ओके, an equation L of y is equal to 1 minus x square into y double dash minus 2xy dash, okay, plus alpha into alpha plus 1 into y, okay, alpha into alpha plus 1 into y, give this equation number 1 is equal to 0, okay, which is equal to 0. Okay, where alpha is any constant. Okay, any constant. It's called Legendre's equation. Legendre's equation. The equation L of y is equal to 1 upon 1 minus x square into y double dash minus 2xy dash plus alpha into alpha plus 1 into y is equal to 0. Okay, so this form of equation is called as Legendre's equation. And equation 1 can be written as can be written as y double dash minus 2 into x into y dash upon 1 minus x square. Okay, plus alpha into alpha plus 1 upon 1 minus x square into y, which is equal to 0. So this is the equation number 2. So equation 1 we can write also in this form. Okay, any doubt up to here?
No, sir.
Here a1 of x and a2 of x are analytic function, are analytic at x is equal to 0. Okay, put x is equal to 0. What is the a1 of x? What is a1 of x? Minus 2x upon 1 minus x square. So this function is analytic at x naught x is equal to 0. This is infinite time differentiable function. Okay, at x is equal to 0. And a2 of x is what? Alpha into alpha plus 1 upon 1 minus x square. Okay, so these a1 and a2 of x are analytic function. Now we have, since the expansion of 1 upon 1 minus x square. What is the expansion? Taylor series expansion. 1 upon 1 minus x square is equal to 1 plus x square plus x raised to 4 plus x raised to 6 plus up to so on, which is equal to summation k running from 0 to infinity x raised to 2k. Is it correct? So this is the Taylor series expansion of 1 upon 1 minus x square. BSc third year झालेलं आहे Taylor series expansion. Okay, so this is the expansion of 1 upon 1 minus x square, which converge. This series convergent. Okay, which is converges for mod x is less than 1. Okay, he दिलेली given series कशी आहे? Is it a geometric series? आहे का geometric series? First term काय? Constant term 1. Okay, टू सक्सेसिव्ह टर्म्स मध्ये काय डिफरन्स, काय रेशो काय त्यांचा डिफरन्स मिळेल. रेशो किती येतो? एक्स रेस टू 4 अपॉन एक्स स्क्वेअर इज इक्वल टू एक्स स्क्वेअर. ओके, कॉन्स्टंट रेशो काय सक्सेसिव्ह टू टर्म्स मधला रेशो एक्स स्क्वेअर आहे तुमचा, कॉन्स्टंट आहे तो, कॉन्स्टंट रेशो आहे. x raised to 6 upon x raised to 4 is also x square. So this is the geometric series. So any geometric series converges for mod x less than 1. Okay, वाचलात का geometric series? Wait a minute. So this is the expansion of 1 upon 1 minus x square is equal to summation running from k is equal to 1 to infinity. Okay, any doubt up to here?
No, sir.
Thus a1 of x is equal to, we can write a1 of x is what? Minus 2x na? Wait a minute. Minus 2 घेतलं काय का? a1 of x, what is the value of a1 of x? Minus 2x upon wait a minute, minus 2x upon 1 plus, sorry, 1 minus x square. Okay, and a2 of x is equal to what we have? alpha into alpha plus 1 upon 1 minus x square. Okay, now look at here. Now, a1 of x is equal to x upon x upon this one is minus 2x into x square minus 1. Okay, 1 minus x square summation keep going from x square. Wait a minute, minus sign anything. E1 of x minus sign घेतला ना इथे minus 2x odd terms k is equal to 0. Okay, a1 of x plus 1 plus 2x घ्या. Okay, plus 2x घेतलं. काय घेतल्यानंतर सांगेन a1 of x is equal to plus 2x upon 1 minus x square plus. Okay, this is 2x upon 1 minus x square. So this a1 of x we can write in some terms of power series. This is 2x. This is summation. What is the summation of 1 upon 1 minus x square? K running from 0 to infinity x raised to 2k, which is equal to 2 into summation k running from 0 to infinity x raised to 2k plus 1. Okay, now any doubt up to here? And a2 of x is equal to alpha into alpha plus 1, and summation of this one 1 upon 1 minus x square is nothing but summation k running from 0 to infinity, okay, into x raised to 2k. Okay, a1 of x मध्ये सगळे टर्म्स कसे येतील? ऑड टर्म्स येतील. ओके, वाय इथे x आहे म्हणून, आणि a2 च्या टर्म्स मध्ये सगळे इवन टर्म्स येतील. 1 plus x square plus x raised to 4 plus. Okay, okay, up to here any doubt?
No, sir.
So these have the series expansion. A1 and A2 have the series expansion. Both the series converges. Both the series converges for mod x is less than 1. Why? Because these both the terms both the series are geometric series. Okay, hence these two series are convergent for mod x is less than 1. Thus, by existence theorem, that is the previous theorem, the solution of L of y, the solution of L of y is equal to 0 on mod x is less than 1 have convergent power series expansion. Have convergent power series expansion. Okay, if a1 and a2 are analytic function, then that is a solution we can write in terms of power series. Okay, now let phi be the solution of L of y. इथून नीट लक्ष द्या, कॅल्क्युलेशन खूप किचकट आहे, नीट लक्ष द्या, अवघड नाही आहे. लेट phi be the solution of L of y is equal to 0 on mod x is less than 1. Okay, so hence we can write phi of x is equal to summation k running from 0 to infinity ck into x raised to k. So this is the power series expansion of phi of x. Now as phi of x, that is phi, is solution of 1 of equation 1. We have 1 minus x square into 5 double dash minus minus 2x into 5 dash, okay, plus alpha into alpha plus 1 into 5, which is equal to 0. So this is the equation number 3rd. If phi is the solution of equation 1, what is the equation 1? This one. Equation 1, then phi satisfies L of y. Okay, hence we can write 1 minus x square into 5 double dash minus 2x into 5 dash plus alpha into alpha plus 1 into 5 is equal to 0. Okay, now this is the phi of x. Then what is the value of phi dash of x? Implies phi dash of x is equal to summation k running from 0 to infinity. Okay, k into ck into x raised to k minus 1. If we put k is equal to 0, then first term is 0. Hence, this summation is running from this
1 to infinity.
is running from 1 to infinity. 1 to infinity k into ck into x raised to k minus 1. Okay, now phi double dash of x is equal to phi double dash of x is equal to directly do summation k running from 2 to infinity. Okay, k into k minus 1 into ck into x raised to k minus 2. Okay, first term and second term काय येईल 0 येईल. Okay, now putting the phi dash and phi double dash in equation above equation 3 using phi double dash and phi dash in equation number 3. Okay, we obtain 1 minus x square into bracket into the summation k running from 2 to infinity ck first, right, 3k, then k into k minus 1 into x raised to k minus 2. Okay, minus 2 into x summation running from k is equal to 1 to infinity k into ck into x raised to k minus 1. Okay, plus alpha into alpha plus 1 into summation k running from 0 to infinity. Okay, what is the value of this one? Ck into x raised to k, which is equal to 0. Up to here, any doubt?
No, sir.
Okay, wait a minute. Going to x, na? X is okay. Wait a minute. Wait a minute. एकच मिनिट थांबा. दोनचे टर्म्स 0. multiply this summation to inside. Okay, this one. Sorry. 1 into this summation is what? Summation k running from 2 to infinity into ck into k into k minus 1. Okay, k into k minus 1 into ck into x raised to k minus 2. Okay, now minus into this summation again. Minus into summation k running from 2 to infinity, this ck as it is, k as it is, k minus 1 into now this x square and this x raised to k minus 2 is what? X raised
X raised to 2.
2. Sorry, x raised to k. Okay, any doubt up to here? काही डाउट आहेत का? कसा आला काल का हे x square आणि x raised to k minus 2. So this is x raised to k. Okay. Now the second and third term is as it is. This one minus 2. Okay, into summation. Now this x and this x raised to k minus 1. Here we get x raised to k. So this is k into ck into x raised to k. Okay, plus alpha into alpha plus 1 into summation k running from 0 to infinity ck into x raised to k, which is equal to 0. Okay, now any doubt up to here?
No, sir.
हा तुमचा k कुठून मिळणार मला 1 to infinity आणि ते 1 to infinity. Now replacing k by k plus 2 in this summation, first summation, replacing k by k plus 2 in first summation, we obtain what we obtain k running from now 0 to infinity. Okay, hence we get summation, replace this k by k plus 2. So here k plus 2 is equal to 2 is meant what? K is equal to 0. K is equal to 0 to infinity. Okay, this is ck plus 2. Okay, so this is k plus 2. This is k plus 1 into x raised to k minus, this term is all terms are as it is, summation it is 0 से का k running from 2 to infinity आहे ना इथे 0 to infinity यायला पाहिजे. 2 ठेवल्यावर काय होईल? Wait a minute. Close out. Replacing k by k plus 2. Okay. K plus 2. K plus 2. Okay. Now here, look at the second summation. K is equal to 2 to infinity घ्या किंवा k is equal to 0 to infinity घ्या. Okay. Value 30 राहील. There is no effect. K is equal to 0 to infinity. If we put k is equal to 0, here we get first time is 0. K is equal to 1. So this is k minus 1. 1 minus 1 is 0. So okay, instead of k plus 2, we write k plus 1. Why? Because we have to take this summation common. Okay, look at it. ck into, this is k into k minus 1 into x raised to k. Okay, minus sign. Now in this summation, look at here. If we put k is equal to 0, the first term is 0 again. So there is again no effect if we run this k is 0 to infinity. So this is k into ck into x raised to k. Okay, plus this alpha into alpha plus 1 into summation running from k is equal to 0 to infinity ck into x raised to k is equal to 0. Okay, any doubt? थोडं किचकट आहे पण समजतं, समजून घ्यावं लागेल थोडं व्यवस्थित. एनी डाऊट अप टू हियर?
No, sir.
ओके, काय घेतलंय कॉमन इथे के रनिंग फ्रॉम 0 टू इन्फिनिटी काय घेतलंय, नंतर हे आपल्याला एक्स रेस टू के एक्स रेस टू के एक्स रेस टू के आणि हे टर्म्स आपल्याला कॉमन काढता येईल. ओके, सो हियर नाउ टेक x raised to k common, so here we get summation k running from 0 to infinity a into the bracket, this is k plus 2 to k plus 1 into ck plus 2 minus, okay, from this one minus k into k minus 1 plus this is 2k. Okay, plus 2k काय मायनस तुमच्या इकडे बाहेर गेलाय, प्लस 2k. ओके, आणि यातला ck पण कॉमन आहे तुमच्या इकडे, प्लस 2k minus this alpha into alpha plus k. ओके, इथे मायनस मायनस तुमचा प्लस आहे, alpha into alpha plus 1, sorry. Okay, so this is bracket complete and this is ck. This whole terms into x raised to k, which is equal to 0. Okay, is it correct? Adjust later. So this summation is common, x raised to is taken common, and this term is as it is. Look at here, x raised to 2k plus is as it is here. This is minus sign. Okay, so this term is k into k minus 1. This x raised to taken here. Okay, and this k into ck minus 2k here, and ck is here. Okay, and alpha into alpha plus 1. Okay, any doubt?
No, sir.
Which is equal to 0. Now look at here, the above equation is true. The above equation is true only if the coefficient of x raised to k for k running from 0, 1, 2 up to so on are 0. Okay, why? Because here right hand side is 0 and this is the x raised to k. Okay, so this is the coefficient of x raised to k. This one is k plus 2, k plus 1, this is the coefficient of x raised to k for k running from 0 to n, 0 to infinity. So if this term is 0, then this equation holds. That's why we are taken the above equation is true only if the coefficient of x raised to k is for k running from 0 to infinity are 0. Okay, that is, what is the coefficient of x raised to k? That is k plus 2 into k plus 1 into ck plus 2. Okay, this minus into bracket k into k plus 1 minus alpha into alpha plus 1 into ck. This is the coefficient is equal to 0. Okay, now from this we get the recurrence relation. What is the recurrence relation? This is the recurrence relation which gives ck plus 2 in terms of ck. Okay, find out the value of ck plus 2. C k plus 2 is equal to, okay, take this toward the right side. What we get here? K into k plus 1 minus alpha into alpha plus 1, okay, upon this is k plus 2 and into k plus 1 into this is ck, okay. So this is the where k running from 0 1 up to so on. Okay, any doubt up to here? Calculation need solve करा बता. Now which is equal to k square plus k minus alpha square minus alpha upon k plus 2 into k plus 1 into this is ck, which is equal to k square minus alpha square. This is k plus alpha, k minus alpha plus this was in this is k minus alpha upon k plus 2 to k plus 1, which is equal to take k minus alpha common, k minus alpha into k plus alpha plus 1. This is sec into sec as it is, into k plus 2 into k plus 1 into ck. Calculation check kara. Is it correct? Which is equal to minus sign taken common. This is alpha minus k into k plus alpha plus 1 divided by k plus 2 into k plus 1 into ck. Okay, any doubt up to here?
No, sir.
Now, this is the ck plus 2. Okay, आपल्याला phi1 आणि phi2 सोल्युशन काढायचे त्याचे लेजेंड्रीज इक्वेशनचे. Okay, in general form मध्ये. So now put k is equal to 0 for k is equal to 0. What we get? C2 is equal to minus alpha minus 0 into 0 plus alpha plus 1 divided by 2 into 1 into C naught. Okay. So this is the C naught. Now for k is equal to 1, what we get? C3 is equal to minus alpha minus 1 into 1 plus alpha plus 1 divided by 3 into 2 into C1. Okay. Now that is equal to minus alpha minus 1 into alpha plus or 2 plus alpha. Okay, this is 1 plus 1 is 2 plus alpha divided by 3 into 2 into C1. Now for k is equal to 2, what we get? C4 is equal to minus alpha minus 2 into काय येणार 2 plus alpha च्या ऐवजी काय येणार आता 3 plus alpha. Okay, directly into 4 into 3 into C2. But what is the value of C2? This one. Okay. Alpha minus 0 is alpha. Okay. Directly. Alpha minus alpha into alpha plus 1. Okay. You can write directly here. Alpha plus 1. Putting the value of C2 here. We get C2. C2 is nothing but what? Alpha into alpha minus 2 upon 2 into 1 na? Yes, into C naught. So C4 in terms of this C naught. Okay, any doubt up to here? Any doubt up to here?
No, sir.
Wait a minute. and this minus minus get plus. आता तुमचं काय C2 इथे मायनस आहे. ओके, आणि C4 इकडे मायनस होता. हा मायनस मायनस काय झाला तुमचा प्लस झाला C2 ची व्हॅल्यू ठेवल्यानंतर. सो दिस इज द व्हॅल्यू ऑफ C4. नीट लिहा बरं का, कॅल्क्युलेशन चुकू नका. दिस इज C4 इज इक्वल टू 3 प्लस अल्फा, ओके, into alpha, alpha minus C4 is 3 plus alpha, alpha plus 1. Wait a minute. This is divided by, this is 4 factorial. 3 plus alpha plus is value of C2 alpha plus 1 ना, alpha plus 1 पाहिजे. Okay, alpha plus 1 आहे C naught ची value into alpha plus 1, this alpha as it is, and this is alpha minus 2 into C naught. Okay, नीट लक्ष द्या कॅल्क्युलेशन कडे. ओके, एनी डाउट अप टू हियर? C naught ची व्हॅल्यू, C2 ची व्हॅल्यू काय, अल्फा इंटू अल्फा प्लस 1 आहे मायनस. सो हियर मायनस आणि हा मायनस तुमचा प्लस झाला, आणि इथे काय ना अल्फा इंटू अल्फा प्लस 1 आहे का, आहे. अल्फा इंटू अल्फा मायनस 1 अँड दिस इज 3 प्लस अल्फा ॲज इट इज, आणि अल्फा मायनस 2 इथे rearrange correctly. Okay, so this is the value of C4 in terms of C naught. Now for K is equal to 3, for K is equal to 3 now, what we get, C5 is equal to minus alpha minus 3, directly we can write 4. Instead of 3 plus alpha is now 4 plus alpha. 4 plus alpha upon 5 into 4 into now C3 now. Okay, then what is the value of C3 now? Look at here. This one is this minus and this minus came now plus. Okay, so this is alpha minus 3, 4 plus alpha. Value of this C3 is equal alpha minus 1, 2 plus alpha. Alpha minus 1, 2 plus alpha into C1 upon 3 into 2 into 1. This 3 into 2 into 1, which is equal to, now look at, rearrange your terms, 4 plus alpha, okay, or alpha plus 4 plus alpha, or we can write alpha plus 4. Alpha plus 4, alpha plus 2 into alpha minus 3 into alpha minus 1 divided by 5 factorial, okay, into C1. Okay, now put K is equal to 4 now. सांगा काय येईल, K is equal to 4, सॉल्व करते का. C6 is equal to minus alpha minus 4 into 5 plus alpha divided by 6 into 5 into C4 na, C4. I'm putting the value of C4 here. C4 केल्यानंतर काय पुट केल्यानंतर इथे प्लस होईल, हा मायनस मायनस. ओके, काय येईल, अल्फा प्लस 3 अल्फा प्लस 1 into alpha, this is alpha minus 2 into C1 divided by, this is 4 factorial, okay, which is equal to, now write first alpha plus 5, okay, then alpha plus 3, then alpha plus 1 into alpha, alpha minus 2 into alpha minus 4 into C1 divided by 6 factorial. Okay, any doubt? Okay, similarly for C7. For k is equal to 5, we get what we get? C6 पॉझिटिव्ह येतो का निगेटिव्ह येतो? चेक करा.
निगेटिव्ह येते सर.
निगेटिव्ह येतोय, मायनस साइन येतोय. हा तेच
आणि सी
म्हटलं.
नॉट येतं.
C2 पॉझिटिव्ह, C2 निगेटिव्ह, C4 पॉझिटिव्ह, C6 निगेटिव्ह. ओके.
आणि तिथं C1 च्या जागी C0 येते सर.
कुठे इथे का? हा C0. C4 ची व्हॅल्यू ठेवल्यानंतर इथे C4. ओके. हा तुमचा प्लस आहे म्हणजे C6 ऑलवेज काय ना निगेटिव्ह ना C6 हा. ओके. म्हणून म्हणतोय कॅल्क्युलेशन नीट चेक करा. दिस इज C6. Now put k is equal to 5 now. What we get? Minus, directly लिहू, alpha plus 6 into alpha plus 4 into alpha plus 2 into alpha minus 5, alpha minus 3, which is into alpha minus 1 into C1 divided by 7 factorial. Okay, so in general, look at here. In general, generalization करताना नीट लक्ष द्या. C2 तुमचा निगेटिव्ह आहे, C4 पॉझिटिव्ह आहे, C6 निगेटिव्ह आहे. ओके. C6 काय निगेटिव्ह आहे. मग काय ना, look at here. In general, C2k is equal to -1/k. एक पॉझिटिव्ह निगेटिव्ह जेव्हा येईल तेव्हा ही टर्म तुमची फिक्स येईल. -1/k. आता लुक हियर. आता काय C2 कधी येणार? C2 काय आला तुमचा निगेटिव्ह आलाय ना. मग पुट k इक्वल टू 1. काय येणार ते C2. मायनस येतोय का? ओके, मायनस येतो. म्हणजे ही कंडिशन सॅटिस्फाय झाली. पुढची काय येणार टर्म? अल्फा येतोय. सो इथे मी ऍडजस्ट काय करणार मग? अल्फा प्लस 2k minus 1. Okay, put k is equal to 1. 2 minus 1 is 1. So alpha minus 1 आहे का C2 मध्ये? अल्फा प्लस 1 आहे का? आहे की अल्फा प्लस 1. ओके. 2 minus 1 is 1. So alpha plus 1 टर्म्स आहे. सो हे कंडिशन सॅटिस्फाय करते. सिमिलरली काय येणार मग इथं? अल्फा प्लस 2k minus 3 अप टू सो ऑन. शेवटी काय येणार? अल्फा प्लस 1 इंटू alpha minus 2 up to so on. This is alpha minus 2k plus 2. So in generalize करताना असे divided by 2k factorial. Okay, is it correct? For k running from 1 to up to so on. So this is the 2k term, C2k. Now what is the odd terms? C2k plus 1. C3 काय तुमचा निगेटिव्ह आहे, C5 पॉझिटिव्ह. ओके. इंटू काय म्हणतो पुढे C0 ना, C1 येणार C0. ओके, इंटू C0. Now C2k is equal to C3 निगेटिव्ह आहे, C5 पॉझिटिव्ह आहे, C7 पुन्हा निगेटिव्ह येते. So hence we can write -1/k. Okay, into, now look at here, alpha plus, okay, 2k. ओके, ते -1 येणार, इथनं -1 जाणार. ओके, ह्यातनं फक्त -1 करत जायचं पुढे. हा काय येईल मग? अल्फा प्लस 2k प्लस 1 ऍड करत जायचं, -2. ओके, अप टू सो ऑन. +1 ऍड करत काय येणार मग? अल्फा प्लस 2 इंटू अल्फा मायनस 1. Okay, similarly up to so on. This is alpha minus 2k plus 1. आणि या टर्म मधनं -1 करत जायचं. कळतंय का? डिवायडेड बाय 2k plus 1 factorial into C1. जनरलायझेशन तुम्हाला कधी करता येईल जेव्हा तुम्ही स्वतः प्रॅक्टिस कराल तेव्हा. ओके, भरपूर एक्झाम्पल सॉल्व्ह केल्यानंतर. So this is the ck term c2k, and this one is the c2k plus 1. These all terms are the हे terms कसे आहेत तुमचे even terms, and these are the odd terms. Okay, any doubt up to here? Hence phi of x is equal to what we have, summation k running from 0 to infinity, okay, ck into x raised to k. So this expansion, this summation we can write in the two forms, expanding this sums. C is equal to k running summation k running from 0 to infinity, okay, into c 2k into x raised to this 2k. Okay, these all terms are even terms, plus summation k running from 0 to infinity. This is c2k plus 1 into x raised to 2k plus 1. Okay, any doubt up to here?
No,
Okay,
sir.
what is the value of this one? C2k. This is summation as it is. K running from 0 to infinity. नीट लक्ष जाता काय. Okay, एकच मिनिट. C not hint. Compare CK to G in general term here. Correct. इथपर्यंत कळते, कळालं का? इथपर्यंत काय अडचण आहे का? इथपर्यंत this can expand in 2x. What is the end of 2k? This one. 2k plus 1. Plus 1. Now putting the value of k running from 0 to infinity now, which is equal to, what is the value of c2k? This one, into the bracket minus 1 raised to k into alpha plus 2k minus 1, alpha plus 2k minus 3, up to so on, alpha plus 1. This is alpha into alpha plus 1, sorry 2, alpha minus 2, alpha minus 4, up to so on, alpha minus 2k plus 2, okay, divided by 2k factorial. Okay, this is the complete into what, c naught plus summation k running from 0 to infinity. What is the ck plus c2k plus 1? Into bracket minus 1 raised to k into alpha plus 2k, alpha plus 2k minus 2, okay, up to so on, alpha plus 2, alpha minus 1 to alpha minus 3, up to so on, alpha minus 2k plus 1, okay, divided by 2k plus 1 factorial into c1. Okay, this is x raised to into x raised to 2k as it is, and this is x raised to 2k plus 1. Okay, now put k is equal to 0 here. या समेशन मध्ये के इज इक्वल टू 0 ठेवल्यास काय येईल आणि या समेशन मध्ये के इज इक्वल टू 0 ठेवा काय येईल फर्स्ट टर्म काय येईल सी नॉट इंटू 1 okay plus summation k running from now 1 to infinity and whole term is as it is here the term okay first term is length into c naught to x raised to 2k okay आता समेशन कुठून रन झालंय रनिंग फ्रॉम 1 टू इन्फिनिटी फर्स्ट टर्म तुमची ही आली दिस इज x raised to 2k आगे इथे पण काय x raised to 2k सॉरी x raised to 1 put k is equal to 0 so what we get x raised to 0 is 1 c naught is as it is x c naught into 1 so this is the whole terms is as it is in the bracket now summation running from k is equal to 1 to infinity and this is c naught into x raised to 2k okay now similarly in the second summation we get c1 into x okay plus summation running from k is equal to 1 to infinity now. Again, this bracket is whole term as it is here. And here we get c1 into x raised to 2k plus 1. Okay, k is equal to 0 to काय येईल इथे x raised to 1 आणि c1. Okay, any doubt? Okay, so this is the phi of x. Any doubt up to here? कॅल्क्युलेशन थोडं किचकट आहे पण सोप अवघड नाही आहे ओके एनी डाऊट अप टू हियर
नो सर
ओके अजून ह्याच्या पुढे कॅल्क्युलेशन खूप आहे सो दिस इज द फाय ऑफ एक्स अँड दिस होल थिंग्स इज नथिंग बट अवर फाय वन ऑफ एक्स अँड दिस इज फाय टू ऑफ एक्स हा तुमचा काय आहे फाय वन ऑफ एक्स हा तुमचा टर्म काय फाय टू ऑफ एक्स ओके अजून 3 ते 4 पानाचं कॅल्क्युलेशन आहे द रिमेनिंग पार्ट we will see in the next lecture okay अर्धाच थेरम झालेला आहे आता आपण थेरम म्हणण्यापेक्षा लेजेंडरीज इक्वेशन okay so the remaining part we will see in the next lecture up to any doubt if no you can leave wait a minute attendance video okay up to any doubt if no you can leave the lecture and thank you for attending the lecture okay the remaining part we will see in the next lecture okay you can leave now thank you